All right, welcome back to the last part of Trickard's crash course in chemistry to help you guys smash this test on Monday. I now want to quickly look at how to use your data booklet and everything that's inside it so that you guys can walk in there on Monday and know where to find the information. Good thing about chemistry, especially year 10 chem, you guys have a data booklet which has all the info you need on it, as long as you know how to use it and where to find that info. So first thing I want to quickly go through is just a quick summary of the periodic table itself. Remember, we've got groups that pop down here. So we've got group 1, okay, group 2, group 3, all the way to group 18. Oh, I can't write G's. Group 18s. The group number also tells us how many valence electrons each of these elements have. So anything in group 2, if I look at beryllium, magnesium, calcium, all of these guys have 2 valence electrons. Because they have less than 4, they're less than halfway full, they're going to kick these off and become a ion of charge 2+, because they've got rid of 2 negative electrons. They got rid of the negative vibes. Anyway, so that's the groups. The periods go across from left to right. So we got period 1, period 2, period 3. Now what these periods tell us, they tell us how many electron shells are present. Okay, so lithium has 2 shells. All right, it'll have 2 electrons in its first shell and 1 in its outer valence shell. That's a quick outline of the periodic table. You guys obviously know that our staircase separates metals left-hand side and then non-metals right-hand side. Right, let's have a look. Scroll down a little bit more. Our solubility rules table. This is important to know because when you guys are going to be predicting observations and seeing if precipitations are going to be formed, you guys need to use your solubility table in order to figure this out. So this table says that to be soluble in water, most chlorides, bromides, iodides, nitrates, any of these guys are soluble in water. When something is soluble, it means it will dissolve. And in our chemistry terms, we say these are aqueous, AQ. So the state is AQ. However, most chlorides are soluble and will be aqueous and dissolve. However, there are some that are insoluble. Silver chloride is one of these. Silver chloride will not dissolve, and therefore we say that it is a solid state. So if you get a question and it's going to ask you, will there be a precipitate that forms? You're going to look for the second part of the formula. So it might be sodium hydroxide or silver iodide. You're going to find the end part. So if we're looking at silver iodide, you're going to go to the iodide section. Most iodides are soluble, however, there are some exceptions. Silver iodide is one of them, so silver iodide will be solid. Next thing we need to look at, if there is a precipitate that forms, so there is a solid, okay, this is called a precipitate. These precipitates will have a color. In general, they will be white. Okay, so 2 colorless ions in general produce a white solid. However, these are the exceptions. So if we get copper carbonate that gets formed, so CuCO3, you will get a green colored precipitate. Lead iodide creates a yellow precipitate. This is the one we did in class. All right, so unless they're on this list, they are going to be white if they form a precipitate. Scrolling down even more, you guys can see other colored substances, and it says that most gases and liquids are colorless. Most metals are silver or grey. However, there are some exceptions. So gold is the classic Gold is the classic yellow color. Copper metal is salmon pink. If you guys have ever seen copper pipes at home, they are like a rusty pinky color. Nitrogen dioxide is a gas, it's brown, and sulfur is a yellow solid. That is it. Oh, and then you need to know how to use your ion sheet. So don't forget, you guys have this. You don't need to memorize the charges of the cations and anions. Remember, cations are positively charged. They are metals. So all of these are cations, these are anions. Bond in ionic bonding. And what happens here is they transfer their electrons. So the cation will get rid of the electron to give it a charge. So hydrogen gets rid of one electron, that's why it's +1. Chloride will accept that one electron, becoming negatively one charged, which is why hydrogen chloride, or HCl, makes such a good pairing. Done.